Dear students, today I will discuss with you some important MCQ from the chapter Atomic Structure. First question: the first emission line in the atomic spectrum of hydrogen in the Balmer series appears at what? Okay, so you see, first question number 1. So before discussing, you should know what is Balmer series, Lyman series. You see, you simply first is Lyman series. First Lyman series. Okay, so Lyman series, in the Lyman series, the spectra, the emission will come or jumping from higher to here N1 is equal to 1. Okay, and it is observed in the ultraviolet region. Okay, second Lyman series, after Lyman series, this is another is second is Balmer series. Balmer series. So the jump up to N2 is equal to, N1 is equal to 2. And it is seen in the visible region. Okay, then your Pascal series, here N1 is equal to 3. Okay, means from higher to 3 up to 3 cell, okay, it will come, and it is observed in the near infrared region. Then Pascal, that is known as bracket series. Here N1 is equal to 4, and it is observed in the infrared region. After bracket, another is Piffon series, and it is N1 is equal to 5, means 7 to 5, 6 to 5 like this. Okay, and it is observed in the far infrared. Then another is Humpis, HUMPHER, Humpis series. Here N1 is equal to 6. It is observed in the also infrared region. Okay. The first question: the emission of line in the atomic spectra for hydrogen in the Balmer series appears. So Balmer series, you take nu bar or 1 by lambda is equal to R 1 by N1 square minus 1 by N2 square. Okay, multiplied atomic number Z square. Okay, so here what will happen? 1 by lambda R 1 by 2. Balmer series is your 2. So N1 is equal to 2, and it is 1 by 2 square 3 square. Okay, multiplied, you are taking hydrogen, so you are taking number 1, so you will get R 1 by 4 minus 1 by 9, that is R 5 by 36. So R 5R by 36 cm inverse. So choice A is the correct answer. Next, in a hydrogen atom, if the energy of electron in the ground state is minus x electron volt, then that in the second excess state of helium plus is what? Okay, see, second question. The ground state En, E ground, energy in the ground state by N square into multiplied atomic number square. Okay, so you are taking minus x by 3 square for helium 2 square. So it is minus x electron volt by 9 by 4. Okay, so 4 by 9 xeV. 4 by 9 xeV. Choice B is the correct answer. Next, in the ground state, an element has 13 electrons in its M cell. The element is what? Okay, 13 elements in the Question number 3. 13 elements, 13 electrons in M cell. So you are right, K, L, M. So K is 2, L is your what? 8, 2s to 2p, then starts M. 3s, 3p, 3d. Okay. So when you consider 3d, before 3d, 4s to be also filled. So it is 2, so it is 2, so it is 6. Okay. So here he said M cell has 13, so 2 plus 6, 8, so it is 5. So total it is your 25. So atomic 25 is manganese. Okay. So choice A is the correct answer. Next. The wavelength of radiation emitted when in He plus element falls from infinity to stationary state would be this one. Okay. So what is the wavelength radiation? Question number 4. You see what is happening? N1 is equal to 1, N2 is equal to infinity. Okay. So 1 by lambda is equal to R, N1 square, N2 square. Okay. And 2 square, because helium is taken. So you will get what? R 101 point, what is given? 1.097 multiplied 10 to the power minus 7 meter inverse. Here 1 by n1 square, 1 by n1 square, that is 1 by, you are taking 1 by n1, 1 by 1 minus, here it is infinity, so 1 by infinity, that is 0. So you will get here 1. Okay, multiplied by 2 square, this is 4. So by solving you will get 1 by 10997 or 967, 1097 multiplied 4. Okay, so solving you will get 2.2 multiplied 10 to the minus 8 meter. Okay, so choice A is the correct answer. Okay. Next, in Bohr's series, in the Bohr series of lines hydrogen spectrum, the third line from the red end corresponds to which one of the following interorbital jumps of the electron from Bohr's orbit in an atom of hydrogen? You see, the Bohr series, lines of hydrogen spectrum, third line from the red end. Okay, so you see, which already explained, that is n1 to n, here n1, question number 5. Here n1 is equal to 2, n2 is equal to 5. Okay, so when n1 is equal to 2, what is the series I explained? When n1 is equal to 2, you see, when n1 is equal to 2, it is Balmer series. Okay, so Balmer series visible, it is observed in the visible region. Okay, so choice B is the correct. B, this is the choice. Next, the correct order of energy difference, question number 6, the correct order of energy difference between adjacent energy levels in the hydrogen atom is what? You see, question number 6, what is given? Energy difference. Energy difference. So when energy difference is considered, what is happening? Distance, as the distance from the nucleus increases, the value of delta E, energy difference, also decreases. It is decreases. Okay. Why? Because the energy level, that is En, is proportional 1 by n square. This is the cause. So by considering this, the choice you are see E2 minus E1, then E3 minus E2, then E4 minus E3. So it is the correct answer. Okay, next question. Which of the following electroning in a transition hydrogen atom will require the largest amount of energy? See here N1 and N1 is equal to 1, N2 is given infinity. Okay, so this is the correct answer. Next, the orbital angular momentum of electron in 4s orbital is what? Question number 8. 4s orbital angular momentum. So angular orbital angular momentum is the formula root over L plus 1 h by 4 pi. Okay, this is the value given. Okay, so you will get here for s orbital, L value is 0, it is 0. So 0 multiplied 1, 0 plus 1. Okay, so 0 multiplied something is 0. So here you will get 0. Choice B is the correct answer. Okay, next, the number of lobes in most of the d orbital are. In d orbital, most of the 4 lobes are present. So choice D is the correct answer. For which of the following options m is equal to 0, magnetic quantum number for all orbitals? So for orbitals, when you consider question number 10, for s orbital, m value is 0. Okay, whatever s orbital it may be, 2s, 4s, whatever it may be, it is m value 0. Then again pz orbital, for pz orbital, m value 0. Similarly, dz square orbital, m value 0. So choice B is the correct answer. Okay, students. Next, which is the correct graphical reference based on the photoelectric effect? Okay, so when you consider photoelectric effect, you see here the threshold frequency nu 0. Here nu 0 is present. Okay, so nu 0, when nu 0 threshold frequency is present, it is in the x-axis and it is in the y-axis. So when threshold frequency, figure 2 is the correct, then you comes to the number of photons is directly proportional to intensity of light. It is also correct. So choice your 2 and 4 correct. So 2, 4 it is D. Okay, next, the time taken by the electron in one complete revolution in the nth or Bohr orbit of the hydrogen atom is what? You see, for complete revolution, okay, you know your time period is equal to distance. Time is distance by velocity. So what is the distance? Circumference of the orbit divided by velocity. So what is circumference? 2 pi r, velocity v. Okay, but we know the radius is directly proportional to n square. Okay, it is known, radius directly proportional to n square, and velocity is proportional to 1 by n. Okay, so here radius is present and here velocity is present. So combiningly it will be nq. Okay, so choice directly proportional to nq. Choice B is the correct answer. Okay, students, have a good day.